Hello, ladies and gentlemen. We're going to do 8.3b today. Just like yesterday, we're going to be doing more guidelines and examples. So today we're going to solve our trig intervals involving powers of secant and tangent. All right, so our first guideline is going to be that the power of secant is even and positive. Okay, and then our rules for that are we are going to save a secant squared factor, and then we're going to convert, and this is going to be because I'm going to use my properties, and then we're going to convert the remaining factors to tangent, and then we're going to expand and integrate. All right, so those are our first set of guidelines. So let's work through our first problem. So we're going to have the integral of secant, that's a secant, to the fourth of 3x times the tangent cubed of 3x, and then I have a dx sitting out on the end. Alrighty, so one of the things that I'm going to show you is that u is going to equal the tangent of 3x, and du is going to equal 3 secant squared 3x dx, because the derivative of tangent is secant squared, and then I have to do the chain rule, okay? And then we do have an identity that we need to remember, and that is that 1 plus tangent squared x is secant squared x. Alrighty, so then what I'm going to is I'm going to rewrite this guy. So this is going to be secant squared of 3x, and then I'm going to have my tangent cubed of 3x. Here's the other secant squared of 3x, and then finally my dx. Okay? Then I'm going to rewrite this guy. I'm going to save this guy for later. So if I rewrite this one, I'm going to end up with 1 plus the tangent squared of 3x, and that's using my identity. And then I have tangent cubed 3x, and then secant squared 3x dx. Whew, that's a lot of writing. Alrighty. And then what I'm going to do is, just like in the other problems, I'm going to expand. So this is going to be the integral of the tangent cubed of 3x plus the tangent to the fifth of 3x. And then I'm going to have secant squared 3x dx. So if you'll remember, we let our u equal the tangent of x. Our du was 3 secant squared 3x dx, right? So now I need to introduce the third. So I'm going to have 1/3 times the integral of u to the third plus u to the fifth, and then I have my du. It's actually way simpler than it looks. Do that integration, and I get 1/3 u to the fourth over 4. I'm going to put parentheses plus u to the sixth over 6 plus c. Substitute my stuff back in, and I'm actually going to distribute this just to kind of clean it up a bit. And so I'm going to get that I have the tangent to the fourth of 3x over 12 plus the tangent to the sixth of 3x over 6 times 3 is 18 plus c. Phew! Alrighty, and so then of course we would report nicely saying that the integral of f of x dx is equal to all of that lovely stuff. Alrighty, so let's do our second guideline. See if you can see it yet. Oop, there it is. This one says that the power of tangent is odd and positive. Alrighty, and then for our guidelines, we're going to save a secant tangent factor, and this is going to be for our du. Okay, then we're going to convert the remaining factors to secants. Whew, so much writing. And then we're going to expand and integrate. All right. So now let's do our next example. Okay, scoot this guy up a little bit. So I want to do the integral of tangent cubed of x over the square root of the secant of x dx. So before I start, I'm going to rewrite this guy. So this is the integral of secant x raised to the negative 1/2 tangent cubed of x dx. Okay? And then if I rewrite this, I guess I could have left it like it was as 1 over secant to the 1 x to the 1/2. Ooh, I don't like it right there. I'm going to put it right there. Let's just clean that up because that just looks gross. So this is going to be 1 over secant to the 1/2 of x. And then I'm going to multiply by a 1, which is kind of tricky. So I'm going to multiply by the secant of x over the secant of x. So this is 1. It's just kind of a fancy one. And then I'm going to have my tangent cubed of x dx. All right, so a couple of things that we need to remember as we start this is that the derivative of the secant of x is secant, that's a cx tangent x, okay, which is why we introduced this right here. And then my identity that we need to remember is 1 plus tangent squared x is equal to secant squared x. Alrighty, so then if I clean this up right here, I'm going to put these guys together, and I'm going to leave this guy, okay, and I'm going to separate this one. So I'm going to do a bunch of stuff all at the same time. So here's my integral, and I'm going to have this, for right now I'm going to write it as the secant of 3/2 x, so that takes care of these guys, right? And then I'm going to write tangent squared x, so I left one of those, and then I'm going to have secant x tangent x dx. Alrighty. So then I'm just going to bring this to the top. So this is the integral of secant to the negative 3/2 x. Tangent squared of x I can write as secant squared x minus 1. And then I have my secant of x tangent of x dx. Whew, that's actually quite tricky. Alrighty. So then, now I'm going to distribute, and remember this becomes 4/2 because it's a 2. So if I distribute these two, I get secant to the 1/2 of x, and then these two guys multiplied minus secant to the negative 3/2 of x. That's the first part. And then I have my secant x tangent x dx. Let me scoot this up so I can have a little bit more room. All right, so now I'm going to do my u substitution. Get me all straight here. So I get u is equal to the secant of x. So my du is secant x tangent x dx. Okay. So now I'm just ready to integrate because this is just the integral of u to the 1/2 minus u to the negative 3/2 du. Well, that was pretty easy. So then if I do that math, if I go up a degree, so up 2 over 2, I get u to the 3/2. Here's the 2/3. And then minus u, if I go up 2, I get to the negative 1/2. Divided by a negative 1/2, so plus 2. Okay. And then I have, of course, my plus c. Substitute my u back in, so I get 2/3 secant to the 3/2 of x plus 2 times the secant to the negative 1/2 of x plus c. Whew, that was a lot of math. This part right here is the part that I think that is the most entertaining, and you needed to see this to be able to introduce this secant, so I have an additional secant on the top for my du. Alrighty, So now I have another guideline. So this would be guideline number 3. And this one says there are no secant factors and the power of tangent is even and positive. And this is going to be the one that we're going to do is like a problem that we did at the end of a homework assignment the other day, or a classwork. So my steps are I'm going to convert the tangent squared factor to a secant squared factor, and that would be using my identities and then, or my properties, and I'm going to expand and repeat if necessary. And if I, let me take a quick sneak peek at my notes, but I believe that we have this example and then a couple of more guidelines. All right, so the problem that we're going to do is we're going to do the tangent to the fourth of x dx. And you can actually do this one with the integration by parts as well. All right, so we are going to turn this into tangent squared of x, tangent squared of x dx. And then I'm going to rewrite this guy using my properties of my Pythagorean identities. So this is going to equal tangent squared x times secant squared x minus 1 dx. Alrighty, and then I'm going to distribute. So this is the integral of tangent squared x secant squared x minus tangent squared x dx. All of that goes like that. Okay. So I'm going to let my u equal the secant of x. So my du is going to be the secant of x tangent of x dx. Alrighty. So then what I'm going to do is before I actually do my u substitution, is I'm going to split this guy up a little bit. So I'm going to rewrite this as the integral of tangent squared x secant squared x dx minus the integral of tangent squared x dx. Alrighty. So then if I do my u substitution, this is going to be, sorry, I was just looking at my work. This is u squared du, okay? And then I'm going to have minus, and tangent squared is the integral of secant squared x minus 1 dx, okay? So this is, come over here, u to the third over 3 minus, and then oh, sorry. Sorry, brain and mouth aren't working at the same speed. I'm thinking, what did I do? But if you remember, whew, that was a brain fart. If I have the integral of secant squared x dx, this is just the tangent of x plus c. So then this is easy to integrate. So then it's going to be minus the tangent of x, and then the integral of a negative 1 is going to be plus x, and then of course I'm going to have a c. I need to substitute this u back in, so this is going to be secant cubed x over 3 minus the tangent of x plus c. Whew! So many things to remember. So if you don't remember your trig identities or the integrals of your trig functions, I would suggest that now is a really good time to start reviewing that. All right, just a couple more things and we are done. So the next guideline says if the problem that you're doing is of the form, and I have secant to the m of x dx, and then the next caveat would be that m is odd and positive, okay? then the suggestion or the guideline that they would like you to use is to use integration by parts, which we've already done, okay? And then the last one is kind of the punt guideline, and it says if nothing else works, if nothing else applies, then the only other thing that you can attempt to do is try converting to sines and cosines. Alrighty, so I have one last little example of guideline number 5 for you, and then we're going to be done. So let's say I have this integral. I have the integral of the secant of x over tangent squared x dx. So this one doesn't match any of the other guidelines that we have. So the first thing I'm going to do is to rewrite all of this using our sines and cosines. All right, so this is going to equal the integral of 1 over the cosine of x. If tangent is in the bottom, then this is going to become cosine squared x over sine squared x because I would flip it, or the reciprocal, oops, hang on, I can't see my screen. That goes away. Come back to here. Whoop, now we're back in business. So because this is just the reciprocal and this is cotangent, well, now I can write this as 1 cosine cancels. And I forgot my dx. Shame, shame. And so I have the integral of sine to the negative 2 of x cosine of x dx. Well, then it's just simple u substitution. So I'm going to let u equal the sine of x. Du is the cosine of x dx. I don't even have to introduce some values, so this just becomes the integral of u to the negative 2 du, and this is add 1, u to the negative 1, divide by a negative 1 plus c. So this is a negative 1 over my u, which was the sine of x, and then I have plus c. And so that really wasn't that difficult. So it is a lot to remember, and I would have these handy with you tomorrow in class while we are working through these problems. Alrighty, that's it for today. I will see you tomorrow.